Good afternoon, everyone, or good morning to some. Welcome to today's webinar, the beginning of a new era in building automation. So today we're going to be talking about the use of artificial intelligence to improve and optimize HVAC efficiencies in buildings. So my name is Mark Carter, and I'm with RealTerm Energy, and I'm happy to have the support of Blake Standen today. He's one of the senior solutions engineers from BrainBox AI. Good afternoon, Blake.
Good afternoon, Mark.
Okay. So before we get into the meat of the presentation, I did want to say a word about TIPS. And TIPS is the interlocal purchasing system. So I know many of the folks on the call today are TIPS members. It's a nonprofit organization for all U.S. states. So across the United States, if you're a municipality, university, K-12 school, or nonprofit, and again, many of the ones on the call today are already TIPS members, but it is free to join. And BrainBox AI was recently added to the list of products available through TIPS. And it can help your organization bypass lengthy RFQs and RFIs because they've already gone through and pre-qualified certain products and run an RFP through a competitive process. So it oftentimes allows you to procure much easier. But again, it is based on your local procurement laws, rules, and regulations. So with that, we'll move on to the next slide. And before we get into the actual use of AI in HVAC optimization, I just have a couple quick slides to talk about AI in general, because it is classified in so many different ways. So if you look at it from a capability standpoint, you may have heard it be narrow AI or general AI or super AI. But when you get to the functionality standpoint, AI is typically broken down into four types. Type 1 is purely reactive. And think of that. So that was the first foray of AI into society. So it really is limited to however it was programmed, right? So it can't function beyond the tasks that they were trained for. But a good example would be IBM's supercomputer Big Blue in its beating of Gary Kasparov. That was a huge milestone. Other examples may be spam filters, or maybe a Hulu or Netflix movie recommendation. That's all using kind of type 1, purely reactive AI. So it's trained to do a particular task and it does it very well. Where we are today and where most AI development is type 2, and that's limited memory. So that's the ability to actually utilize other data flows to improve. And within the AI, you'll talk about machine learning and deep neural networks, but you'll have the ability for it to actually learn and train itself. And that's part of the technology that's used in the HVAC optimization. But examples of that are self-driving cars, chatbots, and as we'll talk about today, AI for HVAC optimization. And where we're moving, and we're probably what the best estimates are maybe 20 years away, is type 3. And type 3 AI is theory of mind. So that's the ability for true decision-making capabilities, right? And also to be able to interpret human emotions and use that in its decision-making on how it interacts with us. So an example might be a C-3PO in the Star Wars movies, where it can discern between, happiness and anger and fear. But in and of itself, it doesn't have those emotions. Its ability to recognize that and then incorporate that in its decision-making capabilities. And then last but not least is what gets the most press, especially in Hollywood, is type 4, and that's the self-awareness. So that's not just being able to recognize emotions, but actually being able to generate and have emotions in and of itself. And that's when you really get to the point of consciousness. And that's, again, you're going to see that in the Terminator movies or Ex Machina. That's what's the most popular when you get to the sci-fi movies. So that's the four types. But it's also important to understand that AI is really kind of an umbrella term. You hear AI for a lot of different things, right? It could be, from fraud detection. It could be used for big data analytics. But it is a larger umbrella term. Within that, in a more sophisticated form of AI is machine learning. So if you've heard that, it's really that machines are actually able to take that multiple data flows and improve at their task with experience And then finally, you want to get into the deep learning or the neural networks, and that's when they'll start to train themselves. So that's the three types of artificial intelligence from an overview perspective. So next slide. So what we're going to talk about today is how do you take that artificial intelligence and actually utilize that in buildings to optimize your HVAC equipment. And really what we're going to talk about is an autonomous HVAC system. And that's an important distinction because much like an autonomous car, right? You're not driving along, it doesn't bark out commands to you or give you a list of you should turn left or turn right or apply the brakes. It actually is a closed loop system. So it's actually making those commands for you. So it's controlling it to turn left, turn right, and apply the brakes. And that's really what we're talking about today in the HVAC system, is not just an endless list of tasks for your facilities team to go and open VAV boxes and change your chiller compressor levels and all that. It's actually a closed loop system. Next slide. And the reason that's important is that if you look at a building, roughly half of the energy is consumed by the HVAC system. And if you look at buildings overall, the Department of Energy will tell you that, the total electricity generation, about 17% of that is allocated toward buildings, and that's on a national scale. So if you look at transportation, industry, and buildings as the three largest components, HVAC makes up a tremendous amount of that greenhouse gas emissions for the electricity and burning of fossil fuels to create that. So, and a great bit of that, 30% is wasted. And the current means of energy efficiency is quite expensive and laborious. So, and the other thing that plays into the effect of inefficient HVAC systems is that you do have discomfort where you're going to overshoot your cooling set points and go beyond your heating set points. You're going to have swings of warmer and colder temperatures throughout the day with a typical reactive HVAC-based system. Next slide, please. So what Blake will talk about today and get into the details of how the operation actually works. But from a results standpoint, you can see on average, you'll see up to a 25% saving in the total building energy. So not just the HVAC system, the total building energy reduction should be in the 20 to 25% range. And you're going to get a corresponding reduction of greenhouse gas emissions by 20 to 40%. But also you're going to significantly improve the comfort. Very important universities, K-12 schools, or any building environment, you don't want to be hot 1 minute and 20 minutes later be cold. And that leads to a lot of, service calls as well to the facilities team, hot and cold complaints. So those are the reasons, and that's the value creation that we'll be talking about today. And for a high level example, next slide, please. Just from a high level perspective, this technology has been deployed around the world. You'll see in 5 continents and I think 17, 18 countries, if not more, but all types from hotels to schools, to universities, to retail. And it scales very nicely, whether it's 10,000 square feet or 1 million square feet. You're going to be in that 15 to 25% energy savings range. And you'll see that's been very, very consistent. And the last slide that I have, and I know there's a lot of universities and schools interested in this technology. One of the early adopters and one of our beta customers in Montreal was the College de Montreal. And we've been working with them for a while. They wanted to be the first college to actually implement AI technology. And we've seen a reduction of their total energy spend of about 32%. So we've seen some significant results. So with that overview and backdrop, I'd like to turn it over to Blake to get into the details of the technology.
Awesome. Thank you, Mark. So first, I kind of want to go over the process of how BrainBox deploys and implements, and we call it a 4-step process. So I'll kind of go through each one. So the first stage is to get connection from the cloud to the BAS. So we have 2 ways of doing that. We have installing an edge device on site that's connected to the BAS network, or we install a software driver if it's a Tritium Niagara installation. And so between the two, 2 to 3 hours, 3 hours being on the long side, typically it's under 2 hours to install. So once we get that cloud connection, I'll call it, we move into step 2, and this is where the data flow out is really important. So we collect all of the information from the BAS system. So all of the thousands of data points that you have currently in your control system today, that gets ingested into the cloud, and we start learning. So the AI needs to get acquainted, or needs to learn and understand how the building reacts to all of its components. So one of the things that we mix with that is we mix weather data from an API. We mix tariff structure data from a tariff structure and greenhouse gas emission real-time data into that cloud environment. So the AI can understand how the building is using the equipment, how the building reacts to the outside weather, and building this thermodynamic model so that it understands how it could optimize it in the future. So it usually takes about 6 to 8 weeks, depending on how big the building is, to learning. And this is where we're not changing anything in the control system. We're just sitting back and trying to get acquainted. So step 3, we move into a process which we call the optimization process. And this is a multi-step process within this process, but it's important to know that when we're ready to deploy, we meet a certain threshold, and I'll get into it a little bit later on a future slide, is predicting the future temperature of each individual zone 2 to 4 hours in advance. That's our threshold. So we need that learning period so that we can make our prediction. And then once we have our prediction at 95 to 99% accuracy, we go into this optimization phase. And we have a building engineer review the control system, review the data, review what the AI is predicting. And he comes up with a subset of AI-driven algorithms to optimize that system based on its understanding. And so this is a multi-step process. He picks the algorithms. We work with the building engineer to set our thresholds. So if there's any thresholds we need to set, and then we have a deployment plan. Then we go through that deployment plan. And then once we're at like a steady state environment where we've deployed all available algorithms that are designed specifically for that HVAC system, we're in this continuous improvement or steady state environment. And this is where we're utilizing energy savings, we're improving comfort. We have our 24-hour monitoring service, monitoring all the AI. And it's just kind of this steady state. And then if anything changes, weather, tenant build out, anything like that, it goes back into learning, and it's continuous improvement. So think of it more of a continuous commissioning type role for this step. Next slide, please. So how does the AI work? So it's important to that Mark went over kind of the AI and all of the buzzwords and going through different, aspects of AI. But the key here is that we're not utilizing, we didn't reinvent the wheel. We took AI, algorithms and AI process from other industries and applying it to HVAC system. So the way this works, and I talked a little bit about that, is taking lots of data from actual temperature to outside weather forecast to mechanical equipment information to number of zones, the variance of temperature, that heat leakage, so that thermodynamics nature of the building, and we put it in this deep learning model. And this example is showing an LSTM type deep learning model. And then what it outputs is the future prediction. So that prediction, so like in other industries, that predictive nature of that self-driving cars, where it can predict when somebody is going to walk out in front or the red light's going to stop or whatever, is taking that prediction. And now that we have the prediction, that 2 to 4 hours in advance future state thermostat, think of it a thermostat on the wall, another thermostat, we can use that future prediction to optimize the sequence of operations in the building to be more efficient, to improve comfort, to mitigate demand charges, and a lot of other things. Next slide, please. So one of the things that we're trying to, overcome is the current BAS control. I wouldn't call it a problem, but it's just the status quo. So conventional DDC systems are designed and installed and programmed for essentially the worst case time of year. So some projected engineering date, time, temperature of the building. I need to meet a certain type of load. So you need to design it. So they're always over designed. And then we have these limited computer processors that run these large, expensive pieces of equipment, and they're not really utilizing any type of, really advanced control. Typically they're very stagnant programmed, reactive programmed. But now we can move into a cloud-based processing, environment, and we could utilize all these more advanced algorithms, AI, machine learning, deep learning neural networks to improve the control of the ability. We just have to make that connection. And so conventional control systems utilize a PID loop that typically is trying to be a preemptive. They're trying to get better the way they're designed, but they're rarely optimized, they're rarely implemented, and they typically go out of calibration fairly quickly. And nobody really goes back and looks at them and redoes them for every single piece of equipment, for every single zone after commissioning has been done. So when we utilize a preemptive control base, so we have that future prediction, we're beating the PID loop way more advanced. And so we shouldn't really even be utilizing the PID loops anymore. The other thing, a conventional control system is they're stagnant. They're in their own little environment. Nobody's watching them 24/7. You may have a building engineer, you may have a control service technician that looks at it periodically. But utilizing, a technology like BrainBox AI is that we have 24/7 AI monitoring teams, one in Ireland and one in Dublin, or one in Dublin and one in Montreal. And those teams, their job is to make sure the AIs aren't breaking anything. They're running efficiently. We have connection. And the AI is predicting what should be happening. So if the prediction doesn't make sense or it's not getting its achieved prediction, it turns itself off, and then it flags in our monitoring center to say, hey, something's wrong with this piece of equipment. I can't achieve my prediction. And that's a level of a fault that we communicate back to the customer. We talked a little bit about the nature of control systems today. They don't have outside data streams. It boggles my mind that a control system doesn't even look at outside weather predictions. I can see that on my phone. It's easy. I can see the week forecast. So it's not even using that. So it's because they're built in the static individual environment. So when you move them to the cloud, you can ingest weather forecasts from humidity, from cloud cover to position of sun, all these different weather streams to utilize a better control strategy. Control systems need retro commissioning periodically. There's always drift. Utilizing a software as a service business like BrainBox AI is it continuously learns, optimizes, and controls the system as long as the service is implemented. AI-driven algorithms to save energy are abundant in our solution. They're very limited, or they take a lot of manpower to develop, engineer, and deploy on site. One of the big things too that's a benefit for BrainBox is traditional control system, all the point names are never standardized. Different technician or different manufacturer has a different subset of what they call the chiller. So what BrainBox does is when we ingest all of that data, we have to normalize it in some way. And we standardized on the haystack nomenclature, and we run with that on all of our buildings. And that's a big value add, because if you were ever to want to standardize on have a new control upgrade or anything like that, that data is yours. Those haystack tags are yours, and you can use that in your next project. Next slide, please. We have connected to all the major manufacturers' control systems, from Siemens, JCI, to Trane, to Schneider, Allerton, everybody. The way we connect, though, is utilizing a backnet network. And over the last 10, maybe 15 years, major manufacturers have standardized on the backnet protocol and moving away from a proprietary nature. So that gives us the ability to be vendor agnostic, and we can control on all those. The other big one that we're not showing here is the Niagara Tritium environment. And I mentioned that early on, is we don't even need an edge device to install. It's a software driver that gets installed on a Jace or a Niagara supervisor that allows that connection to the cloud. Next slide, please. So we went over this a little bit about what is the AI doing. And so this is a graphical look at a traditional zone when a heating event or a cooling event happens. So typically the building is static, the VAV box is not running, or it's at minimum position. And then it gets really hot outside, the sun hits the south side of the window, and it heats up that zone very fast. And so what the current control system does is it reacts to that instantaneous temperature. And so it's like, okay, I need to start cooling. So I need to open up my VAV damper, the air handler turns on second stage of cooling or opens the cooling valve more, and you're blowing colder air into that space. But often you've already lost the momentum the thermal momentum of the space. So what you have to do is you have to overdrive it to get it back down. And then you go into this constant sine waves function. This is really causing a lot of comfort issues for clients and students and everything. So what BrainBox does is when we utilize that future prediction, that 2 to 4 hours, we know that thermal event's going to happen. So we can slowly open up that VAB damper, keep the cooling at first stage for the air handler, and just bring in more air, just to make sure that we stay within that dead band, because typically there's a 2 to 4 degree dead band that we can float in without having to hit those high cooling stages or low heating stages. Next slide, please. Next slide. All right, so we want to show some real life examples. So this is a case study for a building in Texas. It's a smaller building on the 50,000 square foot. The beautiful thing about BrainBox AI is, since we're not controlling any, or not changing any of the environment that's local, so we're not changing control algorithms in the local controllers, we're not changing schedules in the local controllers, nothing like that. We could just simply turn the AI off. And so this is a really powerful tool to prove the value and what we're doing with our customers. So in this instance, we turn the AI off for a week, and then we turn it back on for a week, and we compared side by side, like-minded weather. This is in winter. Temperature outside is the same, humidity is the same, occupancy of the same. Everything is pretty much the same. So we can look at a really easy side by side. Go to the next slide, please. And so this is where we can start looking at, runtime reduction examples. So in this example, these are fan powered boxes. They tended to run a lot more, typically probably for a reheat strategy, or having to turn on because I need to heat the zone up a little bit more with their electric reheat. But when BrainBox was implemented, it kind of cut all of that noise out and really standardized on when the boxes needed to run based on occupancy of the space. So if I know that they need to be 6 to 6, BrainBox AI sticks 6 to 6, and they make sure that by 6 a.m. it's warm enough or cold enough, and then it has the temperature. So it really changed the way the system optimized and reduced the overall runtime, which automatically reduces energy consumption of the space. In this example, it was 76% reduction. So if we start looking at, we can go through each piece of equipment. We're not going to do that today, but chillers are one of the larger energy consumers in the building. And with this example, we saw that we can maintain all comfort in the building without running the chillers at a higher load capacity. So this equates to, supply water at 42. With AI, understanding how the building reacts and all the data sources we have, we are able to run the chilled water system at 49.2 degrees, which equates to energy savings. Next slide, please. Some other examples of runtime reduction between that week, 27% reduction in chiller compressor runtime, cooling valve runtime reduction, heater runtime reduction. So if we look at that side by side, this is a really powerful tool to kind of prove BrainBox results that we are actually doing something in the control system that hasn't been done before. Next slide, please. So when we look at all the different pieces of equipment, we can start looking at the energy consumption as a whole. So one of the key factors, and we didn't go into this too much in the beginning, was understanding the energy consumed per piece of HVAC equipment. So one of the big things that BrainBox does is we do create a virtual meter, a virtual electric meter, real time for every piece of HVAC equipment, because we have to utilize that. We have to understand how different pieces consume different. So the AI makes a decision based on reducing energy consumption. And so when we have all those virtual meters, we can look at a total energy consumption for HVAC, and side by side, week by week, we can say, hey, if you look at before BrainBox, after BrainBox, we had a 36% reduction in energy consumption. Nothing gray about it, very clear. Mark, were you going to go over the financials on this?
Yeah, sure. Thank you very much for that, Blake. We appreciate it. So this is just an example, and this is specifically looking at the TIPS pricing model. Again, you don't need to be a TIPS customer, but those that are can utilize the TIPS program. So this is actually a real world example of a school district that had 10 million square feet. So we're only looking at 10% of that. So just 1 million square feet. So how that would be broken up is BrainBox would actually deploy all the technologies, lay out the algorithms, and during the learning and startup period. And then once you actually go live, then over the first year that we would expect somewhere at about $100,000 net savings for the school. So just kind of gives you a kind of a rule of thumb for every $1 million, you should expect somewhere in the $100,000 range. And that could vary based on what your local electric rates are and energy consumption as well, and your mix of electric and natural gas. But generally speaking, I think that's a pretty good rule of thumb. Next slide, please. And we talked about that it's really not just the energy savings. So I think Blake did mention we have 2 monitoring centers, one in Montreal, one in Dublin, Ireland. So we now are monitoring your equipment in your buildings around the clock. So there's some added value there. And it could be some equipment issues. Maybe you're in the maintenance mode or something broke or somebody leaving doors open, but you're going to get some real-time feedback from that monitoring service. It is agnostic, system agnostic. As long as you have kind of a BACnet communications backbone, then that's really all that's utilized, and it kind of sits on top of a building automation system. So this is not a building automation system. It utilizes it and sits on top and optimizes it. And there are no sensor deployments, right? So you don't have to turn a screw. You're not adding more hardware devices. Really, the only thing that you would be adding is that 12-inch by 12-inch box somewhere probably in an IT closet or close to your HVAC system. But that would be the only device, edge device that you would be adding. You're not required to add any new occupancy sensors, temperature sensors, or anything of the like. And you do have the ability to disengage. And generally, that's used for maintenance period. So you're going into a maintenance mode. You want to disengage that so it's not learning or trying to learn from that period of time where you're actually doing maintenance. But if you ever felt uncomfortable and wanted to turn it off, you do have that capability both through the website as well as the device itself. And we're going to see, and as Blake showed, if you can start making smaller changes hours in advance as opposed to waiting till you hit your cooling or heating temperature set points, you're going to be operating your equipment a lot less often and a lot less harshly. So you're going to see savings in the extended life of your HVAC equipment, as well as lower maintenance cost. Next slide, please. And if you look at BrainBox, so BrainBox was BrainBox AI was started in or launched officially in May of 2019, but it actually was started back in 2017. Their headquarters are in Montreal. See, they're already in 70 cities and 15 countries, and they're impacting, and it's probably close to 300 buildings now. And they do have over 5 research partners, and the company's now is up over 100 professionals. So it's a quickly growing company. And if you look at their impact, the U.S. alone, there's already 21 million square feet installed in 100 plus buildings. So and many more that's already committed. So but you'll see it in Europe, you'll see it in the Middle East. It's very, very widely deployed and growing in Australia, with over 8 million square feet already deployed. And if you look at another 26 properties that are in the process of deploying it now. So, and we've closed our first couple in South America as well. Next slide. Now for RealTerm, so the relationship between RealTerm and BrainBox, so we are a licensed reseller of BrainBox. So we operate in the MUSH market. So the municipal, university, the K-12 schools and the hospitals. RealTerm is, we have offices in Montreal, Canada, Annapolis, Maryland, as well as our newest office is in Sao Paulo, Brazil. So we operate in all those geographies, and we can assist you in not just HVAC optimization, but RealTerm also does a lot in municipal LED lighting conversions, interior lighting, parking lot lighting. So anything kind of energy related for municipalities and educational facilities, we can assist you in. And we are a on the U.S. Department of Energy's authorized ESCO list, and we're a member in the ESCO. We've also been recognized by the World Bank as one of the best practice providers in the world. So with that, if we could go to the next slide. And again, if you are a TIPS customer and that's of interest to you, certainly we can provide more information, but there is a specific contract number. So BrainBox is listed under the Technology Solutions and Services section, but it's contract number 210101. So once we get to that stage and the RealTerm and BrainBox team will be able to assist you with that. But you create your PO and you reference that number and submit it through TIPS. So just like any other purchase you make with TIPS, this is no different. You generate that PO and reference the number. And if you're not a TIPS member and you want to become one, just go to www.tips-usa.com. It's not an onerous process. It's a one page and it's free to join. And I think next slide. So we're going to go to questions. And if you would like to submit some questions online, please do that. While we wait for that, the next page, please, we have a list of kind of some frequently asked questions, and I'm going to ask Blake to help out here. So first, Blake, does the BrainBox AI guarantee the savings?
It's a great question. Thanks, Mark. The short answer is no. And there are a couple different reasons for that. BrainBox operates as a software as a service, and we want to have a fixed monthly fee for our services because, like we mentioned, we do a lot more than just energy savings. We're monitoring, we're providing feedback. There's lots of services, so we just wanted to keep it easy for procurement, and we just say, hey, this is our fee. Savings will vary month to month, but it is our goal to be cost neutral and under the savings level. The other reason is because guaranteed savings contracts come with a lot of money up front. So you have to do your energy model, you have to do your energy audit, usually an investment grade audit, you have to build your MMB plan. And we're talking, $20,000 to $50,000 for an ESCO type of guaranteed savings contract. And that's up front. BrainBox doesn't want to be that. We want to say, hey, install us. We have this learning period. This is where we can get acquainted with the building and start understanding how the building works. And then we'll be able to deploy. And so we kind of wanted to reduce that need for that CapEx project. And so to keep it easy, we just kept it with a single SaaS fixed monthly fee.
Okay. Well, thank you for that. Next question, how does BrainBox AI save the energy or achieve the energy savings?
Yeah, definitely. So we are modulating the control system based on our understanding and the AI's understanding how the building will react futurely, but also utilizing standard control saving strategies, but adding that predictive element to it. So if you think of traditional energy saving strategies like a supplier temperature reset or an optimum start or night flushing or whatever that is, those have been around for a long time and they do save energy. The problem is they are fixed. Somebody walks away, nobody ever looks at them again, and they're still very reactive in the nature of the control system. So when we utilize those strategies, we can add the predictive nature, we can continuously monitor and improve those algorithms, and we can just leave it automatically to run. And that's how we achieve our savings.
Will the implementation be disruptive to our operations and students?
Absolutely not. So the installation is fairly simple. We are adjusting the data, we're learning the facility, we're not controlling anything until we have a clear understanding of how the building reacts to weather and occupancy. And then we have a very detailed deployment plan that we work with the building operators to make sure that they are comfortable and they don't just turn us off. So, there's a little bit of a process and it's a collaborative approach, but our goal is to be very impact less driven on operations and to improve comfort for the students.
Next question, does the artificial intelligence change my set points?
It's a great question. So we do not change space temperature set points. We leave that up to the customer. So if the customer wants 72 degrees with a 2 degree on each side deadband, by all means do that. If they want 70, do that. What the BrainBox does is they change how the HVAC system achieves that set point. So we will change set points on the air handler. or set points on the chilled water system, stuff like that. But it's all inherently to keep that temperature at the zone more often. In fact, we're seeing in most of our data, we see 50 to 60% increase in temperature staying in the dead band because we can anticipate those weather related forecast events.
Does BrainBox AI use a standard framework to manage cybersecurity risk?
So I think the key important thing for these next two commonly asked questions is cybersecurity is very important for BrainBox and important for the world right now with the recent hack. So understanding how we handle cybersecurity, we have a FAQ document that we share with all IT teams. It talks you through a couple different strategies that we utilize, talks about our SOC 2 Type 2 compliance that we're in final review. And it talks about how we could fit the needs of any IT team. So to the second question, do I need to talk to my IT team? Yes, we need to bring them on board. We need to communicate what we're doing. And the key here is that we could be flexible in our solution. We can utilize a customer's ISP. We can utilize a 4G network if it's air gapped. We can, do a couple different things to make the IT team feel confident and comfortable in our strategy. So that's why it's important to bring them early into the conversation.
Okay, well, we have a question that came in. Will BrainBox work in a building with pneumatic control or partial DDC with partial pneumatic?
Yeah, so the short answer is maybe, and I'll walk us through the scenarios here. So in a pneumatic system, let's say it's a VAV type system, air handler, you have DDC controls on your chiller plant. You have DDC controls maybe on your air handlers. Maybe there's a few valves that still have pneumatics, but you still have a controller. But then all VAV box pneumatic systems. So you don't see any visibility into the zones. And if we don't have that zone visibility, BrainBox doesn't know how to make those zones better or run them more efficiently. So we typically stay away from those. There's other ways to optimize the pneumatic system. The second question is if it's partial, you might have some pneumatics on some valves. You might have a few VAV boxes that are still pneumatic, but for the majority of the VAV boxes, they're all DDCs. We can easily exclude the pneumatic zones out of the equation and let them do their thing. And we can focus on the areas that are DDC.
Another question, what services on the BrainBox AI edge devices are exposed to the internet?
What services? Depends on the system architecture, but the way the edge device is if we look at the traditional architecture of the edge device, all it is to establish the connection and to encrypt data. So it encrypts it at rest and it encrypts it at motion. And it also is a one-way port to the internet. So that edge device every 5 minutes collects all the data from the building and it sends it up to the cloud. It initiates the cloud connection from the edge device. The cloud does not initiate to the edge device. So every 5 minutes it sends the data to the cloud and it asks, do you have a recommendation for me to implement down into the control system? If yes, it takes that and drops, and then it closes that port. So I think the key for the cybersecurity aspect of the edge device is it's encrypted, it's VPN encrypted, TLS data in motion and in rest, and it initiates the connection from the device and not from the cloud. So we can't get from the cloud into that box to hack the system.
Another question is, what is the ideal building to deploy the BrainBox?
Can you repeat the question, Mark?
What is the ideal building to deploy BrainBox?
Yeah, so we are looking for BACnet or Tritium Niagara control systems. We are looking at a square feet that probably somewhere over 50,000 square feet because the numbers are a ratio of the size of the building and how much energy it consumes. So we are installed on smaller, 10,000 square foot, retail spaces. But since there are a lot of them, the numbers look good for customers. So if we're talking a school, you could have, 5 or 6 smaller schools huddled onto one BAS network, and that would, be fine if we congregate a bunch of them. So But we have installed on office towers, we have installed in schools, universities, warehouses, retail, malls. So the applications are fairly endless, but some buildings like manufacturing or data centers or some other things are a little bit more difficult for BrainBox because they have different load profiles.
Just got a couple more. I don't want to give up control of my building. Will I be able to see what it's doing?
Yeah, that's a great question, and this is huge. We don't want you to give up control of your building too. So one of the big reasons why we utilize the BACnet priority is it has a priority array. So there's 16 different priorities, and we ride at typically at a priority 9, which is right under the building operator priority level. So think of as a building engineer, I can go override anything I want at a priority 8, and that would override anything that BrainBox is doing. And then back to the visibility side is we do have a dashboard. It tells you your KPIs, so your energy savings, your comfort improvements, and your monetary reductions. But it also gives you a visible chart and seeing what is under control from the AI, what's not under control. And then it has a release button. You can literally just turn it off. It takes about 5 minutes. It releases all the points and it goes back to normal. So you definitely don't lose control. You still need to be in there. Equipment breaks, things happen. You still have to have control of that BAS.
I think I could probably take the next one. Is we have frozen capital expenditures. What are the upfront costs? So this is just a SaaS model. So there is no CapEx cost. So there's no upfront cost whatsoever. Really, you're looking at a commitment of some, probably 6 to 8 hours of time from your facilities team to help us provide us a point list and schematics and drawings, access to the IT network. But there is no CapEx cost. So when this actually gets deployed, the municipality, school, what have you, is cash flow positive from day one. So all the payments are actually paid for out of the savings. And as Blake said, those are fixed cap savings, and anything above and beyond that goes back to the customer. But our goal is to be cash flow positive for the customer day one. And we have one more. Are arenas good candidates?
It's a great question. It's funny you asked. We're in conversations with many arenas, some hockey rinks, some basketball stadiums, and a football stadium. In my thought process and working with these customers that manage these facilities is they find that BrainBox solution could be very valuable in the non-event times, because these buildings are still run all the time, just like a normal commercial office tower. So, and they maybe have an event once a week. And so utilizing BrainBox technology on these arenas during those non-peak events could be huge value, because the HVAC load in those arenas could be huge compared to some buildings. So definitely in conversations, but honestly have not deployed yet.
Good. Well, I think that wraps up the questions. So if we just advance to the next slide, we want to thank everybody for their time today. So if you have any further questions or like information, please don't hesitate to reach out. We'd be glad to talk to you about your buildings and how we may be of service. So again, Blake, thank you very much for your help and assistance today. And we wish all of you a great day and the rest of your week. Thank you.
Have a great day.